Yikes! That hurt for sure. She swung the bat, and the bat swung back to her. Oh, hello there. My name is Paco, and I know exactly why you're here. You want to know what happened back there, right? In that case, you're in the right place. But before delving deeper as to what happened back there, you're going to need to know the 3 laws of motion. Yes, the first law of motion. Newton's first law of motion is the law of inertia. If we want to understand the law of inertia, we have to know what inertia actually is. Inertia is the one responsible for keeping objects motionless or at a constant speed. Have you ever wondered why your coffee continues to swirl even after you stopped stirring it? Well, there you go. Inertia keeps your coffee moving inside your mug or cup. So no, it's not magic, just physics. Law of inertia also says that an object will not move or will continue to move until something or someone disturbs it.
Mandy, why? Mandy! He needs some milk.
So, what happened to Mandy? Let's look again. Right there. Not only did she not maintain her center of gravity, but also another culprit is friction. What is friction? Friction is a force between 2 objects that are sliding past each other. When there is friction, this creates a negative acceleration, meaning it slows down. Moving forward becomes harder because as you try to progress forward, the surface on which you are sliding onto is pushing you backwards. And in the video, since the road is immovable, it only makes sense that Mandy will stop. When Mandy stops, the ideal situation would be that Mandy will not move. And this is what you call equilibrium. But since Mandy has a brain, a pair of hands, a pair of feet, and she's in pain, of course she's going to move, duh. So you might ask me, Paco, what's equilibrium, gum dang it?
Oh my god.
Well, there you have it, folks, equilibrium. Equilibrium, in simple explanation, is when all forces that are acting on an object cancels each other out and the object will be at rest. Now, let's talk about the second law of motion. A while ago, we learned that an object at motion moves because of unbalanced force. And when forces are unbalanced, acceleration is present. Unlike when forces are balanced, then acceleration is 0. For the second law of motion, acceleration plays an important role and is dependent on 2 factors. One would be the mass of the object, and the second is the net force, or the force that is acting upon the object. Well, let's look at this kid over here.
Ready?
Didn't your mom told you not to do that? Ugh, kids, listen to your parents. Let's say that this also happened to an older person who is heavier than the kid, given that the same units of net force were utilized for this event to happen while neglecting gravity. Ideally, the second law of motion tells us that if he was an older person who's bigger and heavier, then he would stop moving nearer the end of the slide than the kid.
Ready?
Here instead of here. So, we can conclude that acceleration is proportional to net force and is indirectly proportional to mass, meaning that the larger the mass of an object, the lower its acceleration compared to a smaller object, given that the same amount of net force is applied to both of them. So, we can say that acceleration is equal to F net divided by mass, or as we usually know it, the second law is also said to be the force of a moving object is equal to the mass of the object multiplied to its acceleration. What is the unit of force? F net is equal to mass, which is denoted as kilograms, divided by acceleration, which is meters per second squared. Putting it together would be kilograms meter per second squared, or to make it simpler, newtons. This concept can also be applied in free fall. Look at this video. Ugh, that surely is painful to watch. Do you know how this can be more painful? If that man is heavier. The reason for this is because if his mass was greater, then the force upon impact is also greater. And we should also remember that when talking about free fall, the acceleration of any object is constant at 9.8 meters per second squared without air resistance. Remember that F small g, or force, is mass times acceleration. The only factor that can increase the force upon impact is the mass of the object, since acceleration is, well, constant. Are you still there? Can you still remember the last two laws of motion? Well, I hope so, because we're at the final law of motion. Have you ever hit your toe on a wooden table and noticed that although your toe initiates the impact, the wooden solid exerts a force back to your toe? The first thought that probably crosses your mind would be, ouch, that hurts, rather than, wow, that's one perfect example of Newton's third law of motion. But actually, these two statements are true. This is exactly what the third law of motion talks about. This law states that when an object exerts a force on another object, the second object exerts a force of the same strength or magnitude in opposite direction. And this is a normal force. Normal force is always perpendicular to the surface of contact. Now, let's look at this video.
Is it two or no?
Cat. We're missing cat.
I don't have mic, so I'll just say out.
Well, as you can see, all the people standing there exerts a force downwards, and in return it pushes them upwards. Normal force is actually special because it changes its magnitude. Let's say if only one person stood there, then there is a normal force, but when another person stood there beside him, then the normal force would double. And if people would keep coming eventually, then this would happen. This happens when the normal force can't match the force that is pushing against it. Well, how about this one? There's going to be no bride next year, I guess. So, what happened here? When the bride threw the bouquet at a wrong angle, it hit the ceiling. Upon hitting the ceiling, the bouquet inserted force onto it, and in return, since the ceiling is immovable, it also inserted the same force back to the bouquet. That's why it went down and hit poor Mrs. Kim's head, and none of her friends will be married next to her. And this one.
You forgot to let go.
Can you remember what force acted on this? Yup, it's friction. And before you get the wrong idea, I'm going to explain it to you right now. One kind of force is not applied on one law of motion only. All forces are related to each other as well as the three laws. As mentioned in the first law, the reason why these ladies stopped is also because of friction. Because as they were sliding through the mud forward, the mud also pushes them backward. So, there you have it. Now you know basic physics, and I hope that you would make wiser decisions than those that you have seen a while ago. Well, once again, this is Paco, and wear your masks.
A huge thank you for everyone who helped me out with making this video, and for you for watching this. It took me a really long time to make, and I appreciate it if you shared it to other people. Thanks.
Find my love.